Hello, hello. What I will do, seeing as some folks may have missed last week's session, I will do a quick recap of what we learned last time. Then I can go through some additional examples. So if you haven't had the chance to try out the practical code from last time, you can feel free to do so at any point. Today we'll kind of go through some additional examples. And Athumani, I have added the additional R script to the Google Drive or the shared folder. It's titled Session 7 RFC, I think, but I can also I'll share the link to we can make sure um, participants can access that code as well. So I'll go through that and then we can go through the quiz as well for the session. But at any point, if anyone has any questions, if anything is unclear, do pause me and we can discuss. Let me share my screen. Alrighty. So here we are. These are the slides from last time. Full screen there. You can go through the slides really quick. So last time we had an introduction to time series analysis in R, just specifically time series visualization. So we started with ggplot2, saw a few different ways on how to manipulate plots, time series plots in ggplot in terms of selecting different time frames, annotating plots, and then adding dual y-axes. We also touched on Plotly, which is a separate package. We talked about Dygraphs, bump plots, and then we kind of went through the code and tried it out ourselves. So I will go over some of the main concepts again. For those of you who were here last time, this will be a bit of a review, but for those who are new, this provides a quick look at some of the main things we covered. So we started off talking about what time series actually means, and it's just a fancy word for any data that's observed over regular periods over time. And visualizing these trends over time allows us to monitor things like disease incidence and effectiveness of various public health programs. There are sophisticated analysis methods as well. So there's methodology called time series analysis, and that's more of a statistical method to quantify changes over time. We did not cover that. Over here, we were focusing simply on visualizing time series data, but for anyone who is curious about more sophisticated analysis, I do encourage you to read about time series analysis. There are some cool methods, both with basic statistics and some more advanced methods with machine learning that you can leverage. Oh yeah, our code file. Thank you. So then we went over the basics of time series visualization with ggplot2. So this is probably the most basic plot you can create using ggplot2. So this is using that same HIV data that we've been seeing throughout this course. This is visualizing total diagnoses over for each month over time. And you can see if you remember from Duncan's sessions, the way we're creating this is we're using the ggplot function and we're adding geom_line to actually plot the line graph. And now because we are dealing with a date axis, so if you remember from the beginning of this course, we reviewed different data types, and R treats dates as its own data type, which is separate from how it treats numbers, but they share a lot of properties with numbers. So dates, you can actually add days, subtract days. You can perform such operations, but R will treat dates as its own thing. And because dates are its own thing, the way you manipulate the date axis is using this function called scale x date. And this is us, we were formatting how that date axis looks and what the different breaks for the how far each axis tick was. So we said each axis tick should be 6 months apart. So that's what we're specifying here. And we also saw different date formats. So when you specify over here, we said date label should be %B, %Y. What that means is %B is abbreviated month, So Jan and percent Y is the 4-digit year. That's the capital Y. So that's what we had lowercase y, so 2-digit year. But it's just a way of formatting the labels in the date axis. So for example, we did an example with today's date. We said percent %A, so that would be abbreviated weekday. This was last week, so Thursday, but not, but just write Thursday instead of Thursday. And then percent %D was the day as a number, so 30 October. Capital B is the full unabbreviated month. And then percent uppercase Y is the full 4-digit year. So this is the way that R lets you actually format how your date looks. Another thing we saw last time was selecting a time frame. So often you have a data set that covers a few years. Suppose you wanted to zoom in to see trends over 1 year or a few months. You can play with, again, using scale X date, you can play with things like date underscore breaks. You can play with limits. This limits argument lets you zoom in to a particular time frame. So over here, we're zooming into the time frame between January and December of 2020, which you can really specify that to zoom into the period that you want. You can also annotate ggplots that visualize time series data. So what I mean by annotation, I mean you can add additional lines. You can also add text. That's what's happening over here. So we have the same plot as the previous slide, but over here we're now adding an annotation about the peak and diagnoses. So this is simply about adding text to the graph, and then we're also adding a horizontal line to represent mean diagnoses over time. So that's what it looks like in this particular graph over here. We also talked last time about dual y-axes. There is a sort of danger sometimes with dual y-axes in that you often have to make sure that you're interpreting them with caution because they're both on the same graph. It could be the case that, they look like they're on the same scale, but we saw a little trick kind of modify the scale that these axes are on. So we said we could multiply one number by a particular coefficient and then divide that axis scale by that same coefficient. So even though total HIV diagnoses only go from 0 to 5, we're able to actually visualize it on the same plot as total diagnoses, which go from 0 to 30. So this is an option if you would like to visualize more than one thing on the same graph. But again, you have to kind of do it with caution because sometimes people interpret these two lines to be the same thing, really, whereas they're not the same thing. Then we saw how to use a package called Plotly. So now we're moving away from ggplot. We're now looking at two packages, one being Plotly, one being Dygraphs. So both of these packages allowed for us to interact with the time series graph that we were creating. So this is quite useful if you have dashboards, for example. So these graphs allow you to kind of hover. You can see the screenshot, so it's hard to tell. But you can, if you hover over your graph over here, it'll show you a measure for that particular time point that your mouse is closest to. And it's quite easy to go from a ggplot to a plotly graph simply with this function called ggplotly. So we saw that last time, but in our example, we also created a plotly graph from scratch, which we'll see again in an additional example today. Then we also saw digraphs. So again, as I mentioned like last time, these are also interactive graphs like plotly graphs. The only difference is that they rely on their own data type. So over here, a digraph, you kind of need this XPS function to first create a data object to plot. So you use the XPS function and you specify. Oh, it's a little bit confusing because X typically is the date variable, right? On the X axis, you have the date, but over here, your X, you're specifying what should be counted over time. So over here, we're counting total diagnoses over time. And then the thing that you're ordering by is the date variable. So you order it by month. And then it's as simple as using the digraph function to plot. And again, it's hard to tell here because it's a screenshot, but these digraphs are also meant to be interactive. So when I hover over different points, it'll actually show the exact value at that point. And we'll see it in an additional example today. We also saw how to split digraphs by gender, for example, in this example, but you can kind of split what you're visualizing by a variable, whether that's gender, whether that's age, whatever you specify. So you can also visualize multiple lines over time, and then when you interact with the graph, it'll display up here. It should display kind of the numbers for each of the categories that you are measuring over time. And then finally, we looked at bump plots. These are a component of GP plots, for example, and they're really useful when you don't have a lot of points. For example, in this particular example we're seeing here, we only had one data point per year instead of one data point per month. And because of that, it was far more interesting to plot it as a geom bump or bump plot um, instead of a typical line graph, which would look quite boring if you don't have that many data points. So this is purely for aesthetics, but it's quite a useful way of visualizing data when you don't have that many time points. And you can even use it to highlight from groups. So in this example, we saw how to plot male versus female diagnoses over time, but then we are only highlighting the female ones by first creating a geom bump layer where all of our lines are gray, and then a second layer where you're just coloring in the female line, which you can do based on your categories. You can kind of pick a category to color in. So this is a really good way of visualizing simple time series data. And that's a quick recap of what we went over last time. So instead of going over the same code book as last time, I have some additional examples to show you today. I'll pause before jumping into those, just in case anyone has any questions. You can feel free to ask them now, or we can continue. Okay. I don't see any hands or messages. We can continue, but feel free to interrupt me if at any point. I see Frank is asking, is time series similar to survival analysis? I think it's similar. But it's not the methods of analysis are different. So in survival analysis, you use something called often you use cost proportional hazard regression, and it creates the output is a hazard ratio which tells you how likely some event is over time compared to another event, given whatever covariate you're interested in, whereas time series analysis is going to tell you not as much about association. It doesn't really give you an answer for how likely am I to, I don't know, develop lung cancer over time. But it's more useful for answering questions like after implementing this intervention, did the rates of lung cancer change before versus after? So the answers might be different research questions, but they are quite related to each other, if that makes sense. And feel free to add Duncan or others if you had experience with these types of methodologies. I definitely have more experience with survival analysis than I do time series, but from what I understand of time series analysis, it's more useful for answering trend related questions rather than exposure A is associated with outcome A.
Yeah, I think I said that to Ashna, and in times you can look at survival analysis and time series. I can see they're actually more or less the same, but for survival analysis, one tends to look at it if you want to if you want to check at what point does an event occur. For example, there was a model that we were running whereby we were trying to look at what happens when the patient dies. So that one was more of a survival analysis because we're trying to look at in the event that this patient dies, what happens? But
data visualization that's mean imenywe
when it actually comes to
data visualization
time series,
imevugwa hapa
it's almost more or less the same, only that now the key point will be in forecasting now, because now you may try to look at what will be the number of deaths maybe from a given disease in the next 4 months, in the next 10 years or so. Yeah, thank you. Ashley.
Thank you. Yeah, hopefully it helps answer your questions. They are technically, I guess, speaking, different, but used for similar things. Okay. Welcome, Amanda. We're just about to go through some additional examples right now. Let me share my screen again. And again, if there's any questions, do interrupt me. And let me zoom in so it's easier for you to see. Over here. Okay. So similar to last time, we will load some packages. We will anchor our code as last time, and we're using the exact same data set as before. So that's me uploading it or importing it into R here. Let's take a look over here. So the same data set where we have HIV cases over time. We predominantly we're going to work with the date of diagnosis variable. There's one example today that actually uses the date of sample collection as well, just to show you a slightly different visualization. And we're using a few of these other predictor or exposure variables as well in our analyses. So this is the data. As last time, we are converting the date column into a date object, and then we are using this for date to create a variable called month. So this I've kind of done in the previous example, we did this step by step. This is me stringing it all together and doing it in one go. As you can do with the tidyverse convention, you can use this. You can use this pipe operator to string together a bunch of different steps. That's what's happening here. So if I run this, I've now created a data set called data time series, where it has month in one column and the number of diagnoses per month. So similar to last time, what this is doing, it's basically counting the number of diagnostic tests done that month. So for example, here, so in January, for example, if we order this by date, January 2019 is the first few, there we go. So this many rows, what it's done basically, it's taken the total number of diagnostic tests done that month, and then it has added it up. There we go, into this particular month. So it's gone through the whole data set and it's added each month how many diagnoses were done. And then it has basically summarized that into a column called number of diagnoses. So this was done over a few different steps last time. It is now just kind of swished into one step so that we can create this summary table that we will now use for plotting. So one thing I remember, we had an issue from last time where we were stuck on, there was a data visualization that showed kind of daily date of diagnoses. So it was using this data set, data diag. This kind of similarly has number of diagnoses per day rather than per month. So it's slightly different from this. And what we were trying to basically play with the x-axis. We were trying to zoom into different months and something was going wrong. But basically the only thing that I think we had forgotten to do was over here, I had this instead of a plus. So it ended up being a dumb mistake on my part, because we're working with ggplot. You don't string lines together using the type operator. So this won't work, as we'll see. It kept giving us this error, or an error similar to this. So it's basically, it was a matter of changing the type operator to a plus. And now you can see that we can, oops, a little bit squish here. But if I zoom in, you can now, oh, where is it? There it is. You can now kind of zoom in and see daily counts here. And we can even make this a little bit clearer. I can even remove, and this is us kind of seeing it over time. So this is just showing 1st Feb to 15th Feb as an example. You can play around with the x-axis and zoom into whatever set of dates that you'd like to zoom into. And you can play with the limits thing. But yeah, the issue here last time was that this was, we had put a pipe operator here by accident. So hopefully that solves the issue. So the next bit, I'll go through a few examples for ggplot, plotly, and digraph over here. So we'll start off with ggplot, then we'll do plotly, then digraph. I'll walk through these. You can see these are not as commented as last time. We can even add comments together if anyone has any clarification required for what's happening in different parts. But I'll walk through each of these step by step, and we can add comments if there's any confusion. So what's happening here with ggplot is I'm using this data time series. Now I'm working with the monthly data set. Over here, I am calling on the ggplot function. This is the workhorse function of point of plot. I'm saying on the x-axis, I'd like month, and on the y-axis, I'd like number of diagnoses. So this should be on the x-axis, and this column here should be on the y-axis. Geom line, this is me specifying the thickness of the line. So I'm saying the size should be 1.1. You can play around with this. 1.1 is totally arbitrary. What I'm doing here also now, adding another layer called geom point. So this will aesthetically make my line more pleasing because it'll basically add a point for each each time point will have a little circle there as well, which I'll show you in a moment how that looks. This is me now labeling my graph. So I'm saying specifying the title as well as the axis label. Again, I'm using scale x date to specify that my date breaks should be every 6 months, and this is how my date label should be formatted. So abbreviated month and abbreviated year. And then theme minimal just kind of gets rid of this. By default, ggplot has this gray background, so theme minimal just gets rid of that gray background. So if I run this, oh, it's even giving me a warning message. Size aesthetic was deprecated. We can use line width. Okay. Well, we can use line width then. There we go. You can kind of see this is what it looks like, number of diagnoses over time. And the points, the geom point there basically adds these. So if I remove that, you'll be able to see it still looks nice, but I mean, the geom point makes it look kind of cooler. And you can play with this. You can change how the date labels look. For example, if I wanted to add a 4-digit year, this will now add kind of crowded, so maybe not the best idea, but it's now adding the full 4-digit year over here. Similarly, if I wanted to change this to the full month, I could do that, but again, it's crowded, so I kind of left it as this, or I could even change it to the number. But you can play around, see what looks visually nice to you, but this is an example of the ggplot version of visualizing this time series data. For the plotly version, it similarly adds works in adding layers. It works a little bit different from ggplot though, because the syntax is a bit different. So the way plotly works is that I use the function plot underscore ly. I have to specify the data set. So again, I'm using the same data set, the data underscore time series. My x-axis is month over here. So where is it? There we go. So again, I want this on the x-axis. I want number of diagnoses on the y-axis. And then over here, I'm saying type scatter. So it's going to put, make sure that the plot is going to be either a line plot or a scatter plot with points. A mode lines plus markers basically adds this. So the markers are the circle bit and the lines are in between. The lines plus markers usually adds both the line and the points. And then again, you can play with the axis titles over here. So if I run the whole thing, you can see it looks actually very, very similar to how the ggplot one looked. But over here, when I hover over it, you can see different time points highlighted. And again, if you remember, Plotly is quite useful in that I can zoom into different sections. If I click on this, I can zoom in, double click to zoom back out. I can pan, so I can kind of move around the graph like this. There's more zoom in, zoom out functions. I can reset the axes, auto scale. And yeah, it's quite handy if you have things like dashboards, because then with dashboards you can actually interact with your data and move things around. The digraph was another way of interacting with the data. So over here, remember we have to create an XPS object before we visualize our digraph. So similarly, I'm using the data underscore time series data set. But over here, I should add this x equals. It'll still work, but just to specify, saying x equals number of diagnoses. So this is specifying what I am counting over time, and then order by specifying the actual time point that is moving along. So month is our time variable. So if I run this line, it'll create that XPS object. You can see in your environment, it'll say an XPS object has been created. This is what the XPS object is like. And then to create the digraph, I simply use the digraph function. I call on this data set. This is a really cool thing I just learned how to add today. We'll see what that looks like. It's called a range selector, and it allows us to basically zoom into various ranges of our data set. Colored blue, this just colors the actual line itself. And then over here, I am labeling the X and Y axes. So if I run this, this is what it looks like. It's actually super cool. So the range selector is this thing at the bottom, which actually allows me to like zoom into different parts of, of the data set. So it'll kind of show you the whole thing and it shows the trend over time. So then here it looks like now zooming into different bits. And you can see as I hover, it'll point out the exact number on the zoom. So digraphs are actually very cool. Who knew? I had no idea you could even use this range selector. So we learn something new every day. This I would totally recommend for people who are creating any sort of interactive data visualization. Quite useful for dashboards and other interactive materials. So would totally recommend the diagram. I'll pause there to see if there's any questions on any three of these three types of visualization before we move to a slightly more complex example. Feel free to either raise your hand or pop a question in the chat. Yeah, it'll be okay. I'm not seeing any questions, so you can again. We'll make sure to share this code book with you so that you can practice. And similarly, if you have any issues, feel free to post on the forum after and we can resolve them together. But the next bit, I'm just going to go over a couple of more complex examples in terms of using some other variables in the data set. So first, we're going to see how you use gender, and this is similar to what we did last time time as well. I'll show you how to split a time series visualization by gender using both ggplot and plotly. I encourage you to try it with Dygraphs as well. We did see an example of it with Dygraphs in last week's session, so I encourage you to try adapting that to this example. So first what I'll do is I'll just recode gender. So I'll recode 1 equals female and 2 equals male using the prior recode function over here that I'm doing in this step. And then similar to how we created the data underscore time series data set, we'll create a data set called data time series gender. Oh, I see a message has popped up. Does it create the number of cases from the date of that particular month? Yes, exactly. Correct. So it'll count the total number of cases in that particular month. That's what the floor date is doing basically. It'll kind of pick the month of the date, and then it'll basically calculate the total number of diagnoses that month. That's what's happening there. And the only difference is that now we are doing it by gender as well. So you can see it'll group by month, which is using this floor underscore date thing to create, and then also we've added gender into this argument. So it'll summarize the number of diagnoses per month and per gender. So if we run this, and again, this may seem a little bit compact. If you go to our examples from last time, basically everything that's happening here happens in a few more steps in the previous week example. You can refer to that code for a more detailed step-by-step version of how we got here. But here I can kind of show you what this looks like now. So basically it's gone. So if it's for January, how many female diagnoses were there in January, how many male diagnoses were there. Whereas the previous one just simply totaled the number of diagnoses in January. So this is a bit more detailed now in calculating the number of diagnoses. That's what's happening over here. So now we can visualize this both as a ggplot and as plotly. So for ggplot, similar to before, we're going to specify the data set that we're using. We'll call on the ggplot function, except now we'll say month should be on the x-axis, number of diagnoses should be on the y-axis after last time, but split the color by gender. That's the only difference over here now is that we're making sure that there are different lines plotted for different genders. Similarly here, adding a geom line and geom point. Remember the warning from last time, line width instead. You can play with this number, make the line width as thick or thin as you'd like. Over here, similarly, now I'm adding labels to the title, X and Y axis, and also to the legend. So color just usually changes legend title. You can even say, and then the minimal. So that's what's happening here. If I say the gender of patient, for example, it'll change it to gender of patient. That's what that is for. But you can now see it's quite a pretty graph as well, same as before. But now we are separating it by gender. And you can do this for other variables as well. The only key is to actually prepare your data set in advance. So if you're doing monthly case counts by something else, just make sure you prepare the data set accordingly and then visualize like this. And you can also use Plotly to visualize it. So again, I'm specifying the data set that I'm using, saying month should be on the x-axis, number of diagnoses should be on the y-axis. The color of my line should differ by the variable gender. Again, here I'm specifying type and mode specifies that I want something like this. I want a line with dots in between. And then I can play with the X and Y axis title. So the legend doesn't have a title here, so we don't need to worry about that. See what this looks like now. Interactive monthly HIV diagnosis by gender. And you can see similarly when I hover over, it'll pick out what's closest to my point. But for example, if I want to see both male and female numbers at the same time, you can say compare data on hover, and now it'll kind of show for each date what's going on in male and female diagnosis at the same time. So again, super duper useful for interactive data visualization. And there I've shown how to do this with ggplot and with plotly. So I encourage anyone who is curious to try it out with Dygraphs as well. We did it in the previous week. You can kind of play with that and play around and see. You can try visualizing. We did it for gender here, but you can try it with other variables. For example, another interesting one could be occupation. Occupation could be an interesting one to visualize differences by diagnosis hospital, although I think there's quite a few hospitals, maybe that's a good one. But any other categories, type of diagnosis, type of case management, these would be interesting ones to visualize over time. In the last example, I'm going to show a slightly different visualization. So thus far, we've been looking at date of diagnosis over time and the number of diagnoses, but we are now going to look at viral load by date of sample collection. So same principles as before, just different variables for novelty, I guess. So what I'm doing in the first part over here is I'm creating a data set where I want to summarize the mean viral load for HIV positive persons by gender. And let's take a quick look at what that data is. So I'm looking at this HIV column. So I'm going to be focusing only on of those who are HIV positive. So those with one over here, we're also looking at viral loads, the VL column, and then gender. We're looking at gender. So these three columns are quite important. And of course, date of sample collection. So that's the other sort of time series column in this data. So up until now, we've been focused on date of diagnosis. What I'm doing here, I'll walk through step by step. I'm saying we're starting with the data set. So the data is the raw data set. We're starting with the raw data set, and we are now filtering. We're only picking out rows where HIV is equal to 1. This only picks out those who are HIV positive, where viral load is not blank. So by definition, everyone who is HIV positive should have a viral load documented, but just in case they don't, this is going to pick out those who have a non-blank viral load. And then this makes sure we're only selecting patients that don't have a blank date of sample collection, which they shouldn't anyways, but this just makes sure they don't. Then in the next step, what we're doing is we are similar to last time, we're making sure date of sample collection is a date, because sometimes it's noted as a character. We're recoding gender, so we are turning one, oh, I think I flip this around. Female, I think one was female and two was male. Oh, and then we are then grouping by data sample collection and gender. So what this will do is it will make sure that for each date that the sample is collected and for each gender, we are now summarizing the mean viral load. So we're creating a variable called mean underscore VL, which is equal to the mean of the viral load. And then finally, we drop the groups to make sure it's sort of returned to its original data set. So when I run all of this together, this is what I get. So over here, I get data sample collection. In one column, I have male versus female gender over here, and then mean viral load for that date and for that gender. That's what's happening here. And over here now, if I go to plot it, if I look at ggplot, for example, here I say that my x-axis should be date of sample collection, y-axis is mean viral load, and the color is gender. Again, I'm specifying that I would like lines and points. I'm playing with the axis labels and the title, and then saying theme minimal. So once I've done this is now what my graph looks like over time. This now is showing average viral load over time by gender, whereas previously we were looking at monthly HIV diagnosis by gender. So you can visualize different things over time based on your research question and what you deem to be informative. So I'll pause there if you have any questions on the example. And you will have this data to play with if you wish. Okay, not seeing any questions, I will move on to the quiz. Let me open up the quiz. Okay. Alrighty. So hopefully everyone can see that. We'll kind of go through question by question. I encourage people to either put their answers in the chat or you can unmute and give your answers as well. So over here, our first question is, what package is good for working with dates? So of these options, what do you think is best for working with dates? Again, feel free to either unmute or put your answer in the chat. Anyone? Who was your last time? Oh yeah, Duncan. Thanks. That is correct. Lubricate. Yeah. What code best represents the following date? Jan 2019. Yeah. So this is the abbreviated month in text and unabbreviated year. Yeah. So which one looks like it's the best option of these? Maybe Frank or Peace? Peace. Nice. That is correct. So lowercase b is the abbreviated month, and then capital Y is the 4-digit year. That is correct. So over here, which line would you modify to change the time frame to diagnoses in 2019? So right now, this is the code that we're looking at. Right now, this code is creating a plot using ggplot, and it is currently focused on plotting data in the year 2020. So what line of this would we change to change that time frame from 2020 to 2019? So which one looks like it should be correct? Scale X date limits. So over here, this is the line that we changed. Basically, we changed this to 19. We changed this to 19 and then to 19. And that would be how we change it to plot 2019 instead of 2020. Okay, next, what function can I use to add an annotation to my ggplot? Anyone? Oh, ICP says answered correctly. Yep. Annotate geometry. So the rest of these are quite similar, but yes, the correct function is annotate. And then we say geom equals text, and then you can add text to your plot with an annotation. The next question asks, how do I change the color of my second y-axis, tick marks and label? So both the tick marks and label on my y-axis, the secondary y-axis, to red. So these are all apologies if it's a little bit difficult to read. on the screen. These are all showing different possible ways to change both the tick marks and label text to red.
Yeah.
I'll give you a moment for this one. It's a little bit tougher to read the answers and see which one is correct. Yes, nicely done. It is D. Over here, what this is doing is you're playing with the axis title, Y right, and the axis text, Y right. So this changes both the tick marks, which is the axis text, Y right, and the axis title, which is the label. So it changes both title and label to red. The next question asks, what is the point of a scaling coefficient in a dual y-axis? When you have two y-axes, remember sometimes if they are not on the same scale, we sometimes use a scaling coefficient as a trick. And why is that useful? Correct. But it's C, it ensures the second axis is scaled up or down to match the first one. So it's a good trick to use, but again, should be done kind of with caution. Okay, so the next one, the answers are split over 2 pages. Let me just move this so they're on one page. So over here, suppose I have a GP plot called graph one. How do I turn that into a plotly graph? What's a quick trick to change a GP plot into a plotly graph with one line of code? Oh, welcome, Joe. We are just going through the quiz from this section. B is correct. So this one, this is how you change the graph called graph one into a plotly graph. Okay. So next question is, what is one important step before creating a digraph?
Yes.
So if you remember, compared to the plotly, digraph is another interactive visualization, but it requires an important step before we create the actual plot. Yes, that is turn the date variable into XDF format. You have to make sure that the data set is now turned into an XDF object, and that relies on you specifying a date variable as well as what is being counted over time. Okay, a couple more. I think there's two more questions. Number 9, when are bump plots particularly useful? Different bump plots kind of make things particularly, they make them more visually aesthetic in some cases. You don't have to use them, but they're quite useful when you don't have that many time points. So they're particularly useful if you're trying to visualize a rather simple data set, but want it to look visually pleasing as well. And then finally, when are interactive time series visualizations useful? More of just a conceptual question. over here are particularly useful because they're interactive. They would not be useful in anything except for HTML dashboards, as Duncan has pointed out. So it wouldn't be really useful if you had to print them out or have them in any sort of static document. It's quite useful if you have a document that you can interact with, an HTML dashboard, or things that you can interact with. That is the quiz. For anyone who has not attempted it yet, I encourage you to attempt it on the Afredac platform. And if there's any issues, do let us know. Well, I'll see if any questions or anything you'd like to try. I know we sort of wrapped up a little bit early. So we have ample time for questions or anything people want to debug if there's any issues with the code that you've been attempting at home in the meantime. But also I understand that in Tanzania, specifically, a lot of internet access is limited. So do not worry if you have not had a chance to try things out yet. We're hoping we can definitely share all the code with you, and then you can take it away. And as the things stabilize, you can try different things out and let us know where you need help. Okay, there. If there's any questions, we can chat now. Or if there's anything other facilitators wanted to add, feel free to add. If there's no questions, we can perhaps wrap up a bit early. Or if anyone would like me to go over anything, we can go over things. Okay. I think we're all good then I can perhaps pass it over to Duncan or Virginia. Or is it Mary J today? Maybe it's Mary J. I'll pass it over to Duncan and Mary J.
Yeah, thank you so much, Ashna, for that wonderful session.
Thank you.
Yeah, so it was really nice to know some of the concepts in particular plotting time series data and actually how to work out or how to use the data that is in date format. So otherwise, thank you so much. And please remember that next week will be our last training session for this training. So please make sure that you also join us there, because we'll now be learning about how to create dashboards, and Ludovic will be our facilitator.